Hi guys, welcome to chapter 16. We're going to cover the immune system and the nervous system in chapter 16. Section A, though, is all about the immune system, okay? So the main function of the immune system is to basically kill germs, okay? It detects, it separates, and it destroys pathogens, okay? Pathogens are the fancy name for germs. The most common types of pathogens that we're dealing with are viruses and bacteria. But there's different problems that fungus and protists can cause as well. But any germ that gets into your body and can make you sick is considered a pathogen. And when they come in and they cause that sickness, that's what's known as an infectious disease. It's caused by a pathogen and it's spreadable. And it can be spread in different ways. It's not just by coughing and sneezing. But we call those infectious diseases contagious. They can spread from one person to another, or even from an animal to a person. Okay. In this section, we're going to talk about these three lines of defense, and it's not necessarily like it doesn't necessarily have to be in this order. Although our first line of defense is definitely our barriers. We're going to talk about that a little bit more, but the germs have to get to us from the outside, and so our body has some somewhat non-specific immediate defenses. Another non-specific, meaning it just targets all pathogens. It's not a specific process depending on the pathogen, would be the inflammatory response. We'll also talk about that in more detail. And then just this very specific immune response. So the white blood cells in your blood will look for and target specific pathogens depending on what it is. Okay, so let's talk about barriers first. Skin is your biggest and first defense against germs. Okay, if your skin is intact, the bacteria or the viruses cannot get in. If we then touch our eyes and pick our nose or whatnot, then those are weaker areas and those pathogens can get in. But that's why we have to wash our hands. Okay. Our breathing passages are coated with what's called a mucous membrane, and that kind of traps the pathogens and attempts to keep them there. And they actually get swept down into our stomach, where the stomach acid takes care of them, as opposed to going into our airways. Once it gets into our airway, once it gets down to our lungs, then the pathogens can actually start making us sick. Okay. Like I said, then the mouth and the stomach have chemicals that work against those pathogens. So that's our first line. That, if everything's working properly, if we're washing our hands, we're not touching our eyes or faces, then that should keep us from getting sick. But we all know that sometimes those things do get in. Okay. So we might have something known as the inflammatory response. Now, the inflammatory response happens with normal pathogens before you get sick, but I think it's easier to think of the inflammatory response with a cut, okay? When you cut yourself, you've opened yourself up to the environment, okay? And your body knows this, okay? So when that happens, fluid like lymph, the plasma from your blood, and specific white blood cells go to that site and they start fighting it. Okay. Blood vessels in the area will actually open up a little bit to get more blood flow there so that more white blood cells can get there. And so that's why sometimes when you cut yourself and maybe it's, not infected yet, but your body's just kind of working on keeping it from getting infected, it might feel a little puffy, and it might be a little red and warm. That's because those additional blood cells right there. That's part of the inflammatory response. Okay. You can also have a fever. Fevers aren't bad things. We tend to medicate fevers because we don't feel good when we have them. But as long as a fever isn't too high, most pediatricians will say if it's under 101, don't take medicine for it, because it's actually your body responding against the pathogens. You might get that with the inflammatory response. You might get that with the full immune response as well. Okay. So this other part of it, and I've got a picture down here. Those special white blood cells that are coming in are called phagocytes, and what they do is they respond to the pathogens that are getting in there, and they literally, like Pac-Man style, like engulf them and eat them up and destroy them before they can cause any problems. That's a process known as phagocytosis. Okay. So you need the additional blood flow to bring those white blood cells in as a response. Now that's a localized response, okay? If that doesn't take care of it, then your immune response is going to happen. And this is a bigger picture. Like this might work before you feel symptoms. This is happening in your body a lot, but this is also happening when you do feel symptoms. Okay, the symptoms are part of the fight, the fever, the stuffy nose, and things like that. But part of the symptoms also are from those cells being damaged by the pathogens. Okay, so there's kind of a lot going on. If you look on page 328, it will talk about this immune response, okay? And these are just kind of the basic steps of it. So we've got these special white blood cells called T cells. Let me get myself out of the way. There we go. These T cells recognize antigens on a pathogen. So remember, the pathogen is the germ. We talked about the antigens when we did blood typing, okay? So it's these little markers. Well, actually, that's an antibody. Here we go. Here is a pathogen. This little marker on it is what identifies it as something foreign to your body. So these T cells will come in and recognize that as an invader, okay? Some of the T cells are going to start attacking those pathogens right away, okay? They're going to produce additional T cells to help with that attack, but some of the T cells are going to go and activate B cells, which is another type of white blood cell, okay? Those B cells, when they come in, they produce these things called antibodies. And those antibodies are like targeted for those antigens, and they come in and they attack the pathogen and they wipe it out. Now, the cool thing is those antibodies stick around in our body and they can help us fight the infection the next time around, okay? It causes the pathogens just to kind of clump together, and it deals with it, okay? Now, this is just some additional vocab that goes along with it. Those T cells and B cells are called lymphocytes, okay? It is a type of white blood cell. There's lots and lots of different types of white blood cells. The phagocytes from earlier, those are a type of white blood cell. These T cells and B cells are called lymphocytes, okay? The antigen is that little marker that I showed you, okay, that identifies it as a virus or a bacteria, and your body notices that. When people get organ transplants, so say somebody gets a heart transplant, that heart has antigens specific to the person it came from. And so when it's transplanted into the new person's body, the recipient's body, their immune system doesn't recognize those antigens, and the immune system will actually start fighting against that organ. So when somebody gets an organ transplant, they actually have to go on medication that kind of turns off their immune system. It shuts down that response. Otherwise, the organ will get rejected. Crazy, right? And then there's those antibodies. Let me move myself back out of the way so I'm not covering any of it. They're produced by those B cells. They target the antigens. They cause them to stick together, and they can't perform their function once those antibodies come in. But it's kind of cool. Like I said, they stick around for the next time those same pathogens come in. And so when you get exposed to something the first time, your body builds up an army. The next time you get exposed to it, your army is already ready. You already have those antibodies, and so your immune system has a leg up, and it's ready to go. Okay. Immunity is, it's kind of what I just said. It's your body's ability to fight things long term. Part of that antibody buildup is your body seeking immunity, so it's ready to defend you at any time. Okay. And if it's working properly, it will do this before you experience symptoms. Okay. We've got two types of immunity to talk about. The first one is active immunity, and that occurs when your own body makes the antibodies. So that immune response we just talked about, your own body is making antibodies, okay? So getting infected, having an exposure is one way to develop active immunity, is to get antibodies. Being a germaphobe, you have to be perfect at it, okay? Because you don't actually give your body a chance to develop natural immunity. When you go out and about, and I'm not talking about during a pandemic or anything, but just in normal times, being exposed to some germs is kind of a good thing because it stimulates your immune system and makes it work. Another way to get your body to produce antibodies is by vaccination, okay? Vaccination is when you are given, you kind of trick your body, okay? You can be given an empty virus that just has the antigens on it. You could be given just part of the virus that will produce a piece of a virus, again, that your body will recognize as bad. Or what else? Like the new vaccines that they've got for COVID are these messenger RNA vaccines, and they actually are producing a small piece of the coronavirus, not enough to actually cause the disease. But all of these things stimulate that immune response. And so the B cells come in and they recognize those antigens and they start producing antibodies. And then those antibodies are there so that if you do get exposed to the actual pathogen, you've already got those antibodies built up. Okay. Herd immunity, it might be something else you've heard about. And that's just this idea of a certain number of the population becoming immune to something, whether that's by getting the illness, whether that's by being vaccinated or what. If enough people are considered immune to a pathogen, what it does is it removes the hosts. Okay, these pathogens can't live without a body to be in. And so if enough people have immunity, the pathogen will actually die off because it needs to find a body fairly quickly, okay? The other type of immunity is known as passive immunity, and this is when the antibodies come from an outside source. You can be given antibodies. Part of the treatment for coronavirus, for COVID, is an antibody treatment, okay? That would be passive immunity, kind of stimulating your own immune system to help with that. If you are exposed to rabies, they give you antibodies for that. It takes too long for your body to produce antibodies for certain diseases, and so the medical professionals will give you antibodies. Like I said, rabies there. When mothers breastfeed their babies, part of what is being transferred from the mother to the baby is a form of passive immunity. So there are antibodies in the initial amounts of the breast milk to kind of kickstart the baby's immune system. Okay. Antibiotics are not passive immunity. I just had nowhere else to put this on the slide. Antibiotics have nothing to do with antibodies. It's basically just a medication, but they only attack bacteria, not viruses. Okay? I think that's all. Wash your hands.